Hey folks, Mr. Dell here. We are looking at a word problem where we'll need to either use that 5D process or somehow come up with an equation to solve this word problem. This is a problem from CPM's course 2, and this is section 6.2.5, number 6-106. So it says a triangle has a base that is 3 times longer than its height, and its area, it has an area of 486 square centimeters. Wants us to use the 5D process to write an equation to find the base and height of the triangle. So if I was to start this question, being something I can draw, I might diagram this, right? So I'm going to draw this triangle that has a base and a height, right? So this is my base, this is my height. It says that the triangle has a base that is 3 times longer than its height. So if I know its height, then I can find its base. So this is again where we have to define what is the independent variable, what is the x. So my x is going to be the height, right? So I'll call this the height. We can also set up a table if that works better for you. You know that the height, and I'll write it down, is my x. And so therefore, what is the base? The base, it says, is 3 times longer. So if I'm making height x, then the base is 3 times longer. So we would say 3x. So I can also put that on my diagram. And so then from there, it tells me the area is 486 square centimeters. So how do we find area? So that's going to where my equation is going to come into play, right? So my equation, remember, area of a triangle, and I'll put it over here for my notes. Area of a triangle is always 1/2 times its base times its height. You're multiplying the base times the height divided by 2, or times 1/2. So if I'm going to utilize this information, this formula for finding the area of a triangle, I'll do that with my equation. So my equation, I know, is going to be 1/2. So actually, yeah, I'll do that. 1/2 times the x times the base, right, is supposed to equal 486. So let's see if we can pick apart this equation and solve it. So first of all, I'm going to look, and I'm going to take my coefficients here, my numbers, and multiply them. So I have 1/2 times x times 3 times x. So 3 times 1/2 is 3/2. X times x is x squared equals 486. So I need to figure out what first of all, I'm gonna have a something squared. So let's get that squared part alone first. Let's isolate the x squared. How do I do that? Well, the opposite here of 3/2, when you have 3/2 times the variable, this is still your coefficient. So we're still going to divide both sides by 3/2, right? Divide by 3/2 because that creates that giant one and isolates as my x squared is what I want. Now keep in mind, 3/2 times, excuse me, uh, 46 divided by 3/2, that's the same thing as taking 46 multiplied by 2/3, right? When you're taking a fraction and dividing by a fraction, it's multiplying by the reciprocal. So you can multiply by 2, then divide by 3, however um, you want to look at this. Oh, I'm going to reduce first. I'm going to cross reduce first. 3 goes into 46. Let's see, 162 times, and then 162 times 2 is 324. 324. Okay, so let's see, 324. Did I do that right? I believe so. Yeah. So now I've got to think, okay, x squared equals 324. So what times what is 324? So that's a bigger number to have memorized for perfect squares, but I'm looking for two numbers that multiply to be 324. And I mean, I could sit there and play around with what times what. Let's see. So I end in a 4. So Let's try 16 times 16. I don't think that's it though. No. About 24 times 24. Yep. All right. So I tried a bunch of numbers to see what would multiply, but sure enough, what I found was 18, right? 18 times 18 is equal to 324. So that means my x is 18. So if 18 times 18 is 324, then x equals 18. Okay. So that now goes back to finding my answer. The height is 18. And if x, so x is 18, so the height is 18. And so 3 times 18 is 54. No, 50. Excuse me. 54, yes. Okay. So we would find my answer. We would say that the base, the base is 54, and we were dealing with centimeters, and the height is 18 centimeters. All right. There we go.